Howdy. That's a Feeding the Right Wolves video. Anyway, science alert. Insect swarms can electrify the air as much as a thunderstorm. Half a century ago, the American mathematician Edward Lorenz famously inquired whether a butterfly flapping its wings in Brazil through a chaotic domino effect set off a tornado in Texas. If he instead asked enough locusts flapping their wings could charge the air with the potency of a thunderstorm, the question might have become equally famous. It didn't, but now we have an answer. A new study on the influence flying insects can have over atmospheric electric fields has found the flapping of a multitude of tiny wings can electrify the air, much the same way as swirling clouds of water vapor can charge the air inside a storm. While this doesn't mean we have to be concerned by biblical plagues of lightning shooting locusts, it could be evidence of a need to take biological phenomena into account when modeling localized patterns in the atmospheric electric field. I just want to note that we are talking about electricity once again. We had the plants, now we have the bugs. And that's mainstream science news. Zoom in close to the atoms making up dust, moisture, and insect body parts zipping about in the air below. Above, you'll find electrons being jostled like loose change in a runner's pocket. Given enough jostling, those negatively charged particles can spill from their positively charged pockets, creating a difference called a potential gradient. In a storm, small ice particles rising in columns of air can rub against larger fragments, tumbling towards the ground, generating a conveyor belt of charges that exaggerate potential gradients between cloud bottoms, and the ground below. Maybe not. It's maybe totally different than we just read, because we have all kinds of surface conductivity anomalies within our ground, magnetic anomalies, telluric currents, and fluctuations in the crusts of Earth, like rivers, lakes, glaciers, volcanoes, and such. But anyway, while the build-up of charge is essentially invisible, the effects aren't. Once the gradient reaches a tipping point, ionized channels form and the balance is effectively evened out in a rush we see as lightning. I have never ever seen any picture or video footage or whatsoever from a big locust storm which would have created lightning. Maybe there is. Maybe there are plenty. I don't know. I haven't seen never anything like that. Even in the absence of lightning, zones of contrasting charges can exert influence over the movements of ions, including various pollutants and dust particles. A variety of factors can determine the magnitude and positioning of potential gradients, from cloud movements to precipitation. Yeah, why the clouds move? They move because of electric currents. They are layered in different layers in our atmosphere, so they can easily move in different directions. And the stronger some magnetic field in the crust is, the higher up it will reach, especially when Earth's magnetosphere is getting weaker. Well, anyway, a variety of factors can determine the magnitude and position of potential gradients, from cloud movements to precipitation, to even showers of cosmic rays. Yes. We had the red aurora, which has just been discovered, or I think it has been some time ago already. We have ozone destroying northern lights. Yeah. Now they take more and more the influence of the sun and all what it can do into climate science. Very interesting. There is slowly, very slowly, it seems, there's a paradigm shift going on since they ran out of explanations and the evidence for them being wrong is just piling up like it's already a very big pile. But until now, nobody had really considered the impact of biological phenomena. Yeah. We always looked at how physics influenced biology, but at some point we realized that biology might also be influencing physics. Yeah. The energy is within the geometry. The geometry defines the energy, defines where are the magnetic fields and how they are interacting. Geometry. That's why we are more or less symmetrical. And by us, I mean all living beings. The tree which stands in your backyard, if you would find the perfect example of this exact tree, what you ever have in your backyard, it would be more or less symmetrical. Take a chicken. Yeah, they're just now staring at me. They're symmetrical. The car tire is symmetrical because it works best. Anyway, that biology might also be influencing physics, says the study's first author, Ellard Hunting, a biologist at the University of Bristol in the UK. We're interested in how different organisms use their static electric fields that are virtually everywhere in the environment. In other words, the aura. Our eye beams are the only thing ever leaving our aura, I think. So they are very important. It's become clear in recent years that insects and other invertebrates can carry charges that gives themselves a tiny potential against the surrounding atmosphere. Yes. The reason why it is possible to pump our blood in the very, very, very fine veins, because I think they get sucked into there through the charge differential between some auroral parts or layers and the electric charge of the body itself. It's become clear in recent years that insects and other I have read this already. Baby spiders might even use this trick to launch themselves into the sky. But how this itty-bitty potential aggregates in swarms has never been measured, so Hunting and his team ventured out to a University of Bristol School of Veterinary Sciences field station to await the swarming of one of their many honeybee colonies. Using an electric field monitor and a camera to monitor the bees' density, the researchers tracked the local potential gradient of a swarm in transit. For 3 minutes, the insects zipped past, raising the potential gradient overhead by up to 100 volts per meter. A later analysis confirmed the voltage was released to the swarm's concentration, allowing the researchers to predict with reasonable confidence how a given number of bees buzzing through a particular patch of air might affect the atmosphere's charge. Knowing their estimates held up to testing for bees, the team applied the same rationale to other insects that swarm. Taking the individual charges for locusts and scaling it up to plague-sized numbers, the researchers calculated a significant locust swarms could potentially generate densities of charge not unlike those found in electrical storms. All storms are electric. Interdisciplinarity is valuable here. Yeah, it's always and everywhere a value. Only through achieving getting the biggest picture possible. You will see the picture as it is and not just focus on a small part behind a corner somewhere. Electric charge can seem like it lives solely in physics. Electric charge can seem like it lives solely in physics, but it is important to know how aware the whole natural world is of electricity in the atmosphere and in the ground and in the heavens everywhere, says Gilles Harrison, an atmospheric physicist from the University of Reading. At the other end of the scale, yeah, cosmological Birkeland currents, maybe. That tornado risking agent of chaos, the butterfly, which is still crap, will need to work together in vast numbers to have any hope of altering the atmosphere's voltage by an insignificant extent. Probably for the best of that. This research was published in Science. No, not one single picture. Not one single picture. Where are the locusts which are creating the lightning? Anyway, I found this interesting. I found it so interesting that, despite all the odds, I made this video. It's one thing to try to tell people what to do if there is an overabundance of certain energy. The other thing is doing it. By myself. Yeah, these are very hard times for everyone. And I try to really do what I preach. And it's not easy. It wouldn't be easy. The other way around, neither. Many of you know. So I choose the truthful uneasiness. Let me quote Zack de la Rocha. It had to start somewhere. It had to start sometime. What better place than here? What better time than now? Thanks.